Let's use our reduce and return method to work another example. So I picked this circuit because it looks a little bit different. I don't want it to concern you that it looks different. Just you can still recognize your series and parallel configurations here. So I think notice I'm going to start, now we've got the source in the middle of our circuit. So again, I'm trying to get as far away from the circuit as I can. So I'm going to start with R4 and R5. And I recognize that there's only one connection between them. They're only connected on one side, and there is nothing else connected between them. So what that means is the current through R4 is the same current through R5 because that means they're in series. Okay, so I would call this RA up here, where RA is equal to R4 plus R5, 14 plus 6, or 20 ohms. Okay, so my first step, I'm going to redraw my circuit, remove R4 and R5, and put this RA back where I took those from. Okay, so pull this down a little. And here is my RA. Now I'm going to draw the rest of the circuit here. All right, so that was step 1, and this will be step 2. So I'm going to scroll down a little because now we're solving for this circuit. So you can treat each step as its own circuit and just reduce as much as you can on that particular circuit. Now, what do we want to do here? Well, we might have to get out the colors again because here I can see that my RA is connected to the 20 ohm on that side. Notice also it's connected to the 20 ohm on this side. So that means those two 20 ohm resistors are in parallel. So if I combine them, I would have RB. We'll call that RB. Now, and then I'm going to put it back between the blue and the green. So RB in this case is the two 20s in parallel, which if you recall, equal resistors in parallel, you can divide by how many you have in parallel. So 20 divided by 2 would also give us 10 ohms. And I'm going to redraw my circuit again. There's the original 10 ohms. Here's my 20 volt source and the 5 out here. Now, where does that 10 ohms go? Well, I'm going to draw it over here where the 20 ohm was. That's RB. I'm going to draw it right over there. It really doesn't matter much. Let me clean that up a little bit. It really doesn't matter much as long as it's connected where that blue side was and where that green side was. As long as it's connected in that same place, you're fine. Now what do we want to do? And I'm going to call that step 3. Now, what will I do next? I'm going to combine the two 10s. Looks like the two 10s have one connection between them over here, and there's nothing between the two 10s, so they must be in series. So I'm going to call that RC. So I'm just going to add those because they are in series. And I'm going to redraw my circuit one more time. All right, so now at this point, if you're starting to get pretty familiar with the process, you may not want to draw the circuit another time after this, but I'm going to continue till I get just one resistor value with in series with my source. So notice the 10 ohms. A 10 ohm resistor is connected to the positive terminal of my source and also to this 5 ohm resistor here. And on the bottom, it's connected to the negative terminal of my source and to the 5 ohm resistor on the other side. So that tells me a couple things. First, the 10 ohm resistor and the 5 ohm resistor are in parallel, even though they're separated by the source. But they're also in parallel with the source, which pretty much tells me that I've got 20 volts drop across each. However, I'm going to save that until my next step and put it all together at the end. So my RT in this case is going to be the parallel combination of the 10 ohm resistor and my 5 ohm resistor. Oh wait, that's wrong. That's a 20 ohm resistor. I should make that a question, so you have to catch my mistakes when I'm working through this. Ah, there we go. That's much better. So that gives us 4 ohms of total resistance. And I'm going to draw my circuit one more time. And you can put that 4 ohm resistor on either side, doesn't really matter. And there is my step 5, and the most simplified my circuit can actually get. All right, so now that we know this, we know that RT is 4 ohms. That allows us to find our source current, which is the supplied voltage divided by that total resistance. So we've got 20 volts divided by 4 ohms, or 5 amps of current. That's coming from the source, from the positive terminal, and returning back to the negative. That also gives us our 20 volt drop across that 4 ohm resistor. And now we're ready to move up another level. So where is, on step 4, where would that 5 amps be? Well, it's coming from the source, what's right here. Or you could say it's down here, coming into the source from ground. Okay, same thing. Now, we have a 20 volt drop across each of our resistors because they are in parallel with the source, and because they were in parallel together, and we had 20 volts drop across the combination of the two. So that will help us find our currents through each of those resistors. So the current through that 20 ohm resistor is the voltage drop across the 20 ohm resistor divided by the resistance. Again, just Ohm's law all day, right? 20 volts over 20 ohms means I've got 1 amp of current through here. And that's going this way. And then the current through my 5 ohm resistor, we've got voltage drop across there divided by the resistance. So you've got your 20 volts across your 5 ohm resistor there, or 4 amps this way. So notice at this node or junction, you've got 5 amps coming up from the source, 1 amp going through the 20 ohm resistor, and 4 through the 5 ohm resistor, so that adds up to 5. And we've got all of our voltage sources. We're ready to move up to step 3. So you want to transfer everything we've learned here. We know we've got 5 amps coming from the source, and I'll even draw it down here, 5 amps coming back to the source. The 5 ohm resistor on the right that doesn't change from between these steps. So I'm just going to indicate that we've got 4 amps of current there and 20 volts drop across the 5 ohm. That stayed exactly the same, so I just transferred it from 4 up to 5. Now on the left-hand side, what stayed the same from step 4 to step 3 is that my 20 ohm resistor I've split into series resistors. Now what's the same for series resistors? The current is the same through series resistors. So that 1 amp, I still have the 1 amp going into both of those resistors. I think that was RB. Okay, so if I have 1 amp of current going through each of those resistors, I can find the voltage drop across each. So the voltage drop across RB is going to be the current through RB times RB. So I've got 1 amp of current through 10 ohms of resistance. So I must have 10 volts across there. And notice I'm drawing that drop in this counterclockwise direction because my current's coming in from the right this time to the left. So that means that my voltage drop is going to be from the right to the left. That's driven by that current direction. Okay, so then I'm looking for the voltage drop across the 10 ohm resistor here. So the current through the 10 ohm times the resistance of the 10 ohm. I've still got 1 amp of current there because it's in series. So it looks like I've got 10 volts drop here too. And that makes sense. Our series resistors divide the voltage, and they're dividing that 20 volts down equally because they're equal resistors. So that makes sense as well. I have found everything at this step, so I'm going to work back towards step 2 here and just copy up everything that stayed the same. All right, so my 20 volt source, I still have 5 amps of current coming from there. I still have 4 amps of current through my 5 ohm resistor. Notice I didn't draw that current up here, okay? There's a reason. We know the current through the 5 ohm resistor is 4 amps, but it looks like something a little different might be happening up in this portion of the circuit. So we're going to wait before we define that current for a little bit. We also know that the current through my 10 ohm resistor on the left is 1 amp. So I'm going to draw that 1 amp right here. Again, I'm staying away from this portion of the circuit up here that's in colors right now, because that's where we split this 10 ohm resistor back into parallel resistors. So we're going to see that current dividing up there. All right, so what do we know? Well, we know we've got 10 volt drop across the 10 ohm RB. When we move back up a step, we're splitting those back into parallel resistors, and parallel resistors have what in common? They have the same voltage. So we're going to see this 10 volts drop here and also across RA. And I forgot to put in my 10 volts there and my 20 volts there. Okay. So we have everything for step 2. Oh no, we haven't found our currents through RA and the 20 ohm resistors. So let's find our current here. So IA is going to equal VA over RA. Well, the voltage drop across RA is 10 volts and RA was 20 ohms. So that means half an amp we'll see through RA, and it's going this direction because that's the direction of our voltage drop. So we know that the current has to be going in that direction. And then the current through the other 20 ohm resistor would be the voltage drop across that resistor divided by the resistance. So we have the same 10 volts there across another 20 ohm resistor. So half an amp would be going through here as well. So notice we've got half an amp coming from RA, a half an amp coming from the 20 ohm resistor. They would combine, so you've got your 1 amp down here, and that makes sense, right? Okay, so let's just step back through one more. Actually, let's look over here, just you know, to see what's going on. We've got 4 amps leaving, going through that 5 ohm resistor, half an amp leaving, going through RA. So what does that mean for the current here? It would have to come in because I don't have any currents coming in, and it looks like it would have to be 4.5 to match the current leaving up and down. And notice what that means for this portion, or this node or junction. We've got 5 amps coming from the source with half an amp leaving this this way, 4.5 leaving this way. That's a total of 5 leaving and 5 coming in. So that actually makes sense. So we know everything in that portion for that number 2 circuit. And now we're ready to go back to our original circuit. Let's just start drawing in everything we know. We've got 5 amps here. I'll even draw in these currents as well. We've got 1 amp here. 5 amps here. 4 amps here. Then we drew half an amp here, which is also here. Okay, so those are all of our currents. What voltages do we know? We've got 10 volts here, 10 volts here, 20 volts over here. Now, what changed from step 2 up to step 1 was this RA. We split, we're going to split that 20 ohms of resistance back into series resistors, which divide our voltage. And so how do we figure out what those voltage drops are? V4 would be I4 times R4, and I4 we found was half an amp. R4 we found is 14 ohms. So that must be 7 volts. All right, and V5, I5 times R5. We have the same half an amp there because it's in series with R4, 6 ohms there, so we would see 3 volts drop there. Okay, so these series resistors which divide our voltage, they actually divided the 10 volts we had across RA into 7 and 4, 7 and 3 right there to make 10. That's our voltage divider. Okay, so there's just about everything. Let's see, what were we looking, what we were asked for? We found everything we were asked for except for maybe VA. So let's talk about how to find VA. Here's how I would find VA. Right here, we start with our ground, or V equals 0 at this point. And then let's just pick a spot to travel. As we travel up through that resistor, what do we see in terms of our voltage? We see a voltage rise of 20. So if we were to measure our voltage at this point, we would see that we had a positive 20 volts there. Now, if we continue on through this path, what do we see when we encounter R5? We see a voltage drop. We're going from plus to minus here in that upward direction. So we would drop 3 volts. So on this side, whoops. So on this side, we would measure 17 volts, and that happens to be VA. Now, what if you wanted to go a different direction? Let's start over here. V equals 0. What happens when you encounter this R1? You rise at 10 volts. So over here, we're at a positive 10 volts. And then what happens after this? On this direction, you see a rise of 7 volts from minus to plus 7. So on this side, we'd be measuring plus 17 volts, which is what we already found for VA. Okay, so there's a few different ways you can work through this and figure out what those voltages at certain points in your circuit are. So if you need to, start the video over and work through the circuit yourself, then replay my solutions and see if you got all the same answers, or just skip to the end and see if you did.